Hello, all. My name is Reginald Santil, and today I will be discussing my research on unit testing. Today's agenda will be discussing unit testing, using JUnit testing, assertions, basic unit test, exception handling, unit test, mocks orange stubs, test-driven development, key qualities of a good unit test, or makes a good unit test versus functional test versus integration test, software testing, software testability, unit testing, mock object, and technical resources. Now let's begin. The Clean Code Talks, unit testing. Writing testable code is essential for effective testing. Ideally, the same person should write the code and the unit test to ensure testability. Testable code involves practices like good object-oriented design, dependency injection, and test-driven development. Scenario-based testing. This type of testing is done on an entire system. Scenario tests serve the purpose of verifying that all components are properly integrated. They can prove that a system works, but it often leads to slow and flaky tests due to complexity and unpredictability of real-world scenarios. Flaky tests are unreliable and may produce inconsistent results. Medium-level test or functional test involve breaking down the system into individual components and testing them in isolation, leading to better reliability and faster execution. Unit tests focus on testing individual classes or components of the system, providing high confidence in test results and fast feedback loops. Unit tests are extremely fast and pinpoint the exact cause of failures, making debugging easier and more efficient. Unit testing is highly recommended as it provides better testing coverage and faster feedback compared to scenario-based testing. Additionally, it complements functional tests by ensuring that individual components work correctly. Dependency injection. This is crucial for separating concerns in code, allowing for easier testing by replacing dependencies with controlled subtitles or substitutes rather. A seam in the code enables the substitution of dependencies during testing, facilitating isolation and control over test scenarios. Dependency injection involves requesting dependencies in a class's constructor rather than handling instantiation within the class. The new operator separation facilitates subclassing and polymorphism, enabling easier testing. Mixing object creation code with business logic makes testing difficult because it prevents isolation of components for testing. Object graph construction and lookup should be separated from business logic to simplify testing and make it more manageable. Unit testing with the separation of object instantiation responsibility from business logic is crucial for effective testing. Now, on to the next section, using JUnit testing. So JUnit is a free open source framework for automating and testing processes in Java programming. It is essential for testing the functionality of small units or pieces of software to ensure they meet the provided business rules. JUnit is not part of the standard Java class libraries, but is included with popular IDEs such as NetBeans, Eclipse, and IntelliJ. Good unit testing is crucial for the success of an application, as it helps identify bugs to ensure the expected behavior of the software. JUnit provides automated testing and validation, which is more efficient and reliable than manual testing methods. Unit testing is just one aspect of software testing. Integration testing and performance testing are also important for ensuring the overall functionality and performance of an application. JUnit is primarily focused on unit testing and is not designed for integration or performance testing. To use JUnit, you need to download the JUnit jar file from the junit.org website and add it to your project's class path. Optionally, you can also download Hamcrest jar file, which extends JUnit's capabilities with additional assertion methods called matchers. JUnit can be used within IDE or from the command line, and it can be integrated with build tools like Maven for automated testing and a development environment. Now, our next section, assertions. JUnit utilizes assertions for its unit test cases, providing overloaded assertion methods for various data types, objects, and arrays. Assertions compare expected and actual values for equality, inequality, and other conditions. Examples of assertion methods include assert array equals, assert equals, assert false, assert not null. Note, the order of parameters in an assertion statement is expected value followed by actual value with an optional message parameter. Now, on to basic unit test. JUnit test can be executed easily within IDEs like NetBeans, providing detailed feedback on test results. Meaningful messages in assert statements facilitate error identification and debugging. JUnit tests are automated and do not require human judgment, ensuring consistent and reliable testing. Naming conventions for JUnit tests involve adding the suffix test to class names and creating them in a separate package. JUnit tests can be aggregated into test suites to execute multiple test cases simultaneously. Now, on to exception handling. Testing for exceptions is crucial to ensure that programs handle errors gracefully. JUnit allows for testing specific exceptions by specifying the expected exception class in the test method. Examples include testing for index out of bounds exception and arithmetic exception. By specifying the expected exception, JUnit can verify if the program throws the correct exceptions. Testing without specifying expected exceptions can reveal unexpected errors and help identify areas that need exception handling. JUnit provides a feature to temporarily ignore certain tests, that is, using the @ignore annotation. This is useful for disabling tests that are not relevant at the moment. Now, on to the next section, unit test. Unit testing became a signature activity of extreme programming, or XP, and quickly led to test-driven development. Unit testing is a common practice in software development, but is often ill-defined, leading to confusion. There have been definitional concerns about the term unit test since the early days of XP, with various interpretations existing. Common elements of unit test include a focus on small parts of the software system, being written by programmers themselves, and being significantly faster than other tests. Unit test, solitary or sociable. The distinction between sociable and solitary unit test is important in unit testing. Solitary unit tests involve using test doubles for collaborators to isolate the unit under test, preventing faults in collaborators from affecting the test results. Sociable unit tests, on the other hand, allow communication with real collaborators, assuming they are working correctly. These tests focus on the behavior of a single unit, assuming other components are functioning correctly. Early XUnit testing in the 90s did not prioritize solitary tests unless communication with collaborators was awkward. With the popularity of XUnit testing in the 2000s, the notion of solitary test resurfaced, particularly with the rise of mock objects and frameworks for mocking. Two schools of XUnit testing emerged: classic and Moxis styles, with Moxis insisting on solitary unit test and classicists preferring sociable test. Now, let's discuss speed in regards to unit testing. Unit tests have common properties: small scope, done by the programmer, and fast execution. The ability to run unit tests frequently is a key characteristic of self-testing code. Running unit tests after any code change helps catch defects early, making it easier to identify the cause. When running unit tests frequently, it's common to only run tests relevant to the code being worked on, known as the compile suite. Continuous integration involves running a commit suite, which typically includes all unit tests and may also include broader tests. The speed of unit tests and test suites varies among individuals, with different preferences for acceptable durations. The goal is to have unit test suites run fast enough that developers are not discouraged from running them frequently, ensuring bugs are detected quickly and can be addressed promptly. Now, mocks aren't stubs. Mock objects are special case objects that mimic real objects for testing purposes. Most language environments have frameworks to create mock objects, facilitating testing. Mock objects enable a different style of testing, emphasizing behavior verification. Mock objects encourage behavior verification, focusing on interactions rather than just state. The community around mock objects uses them to develop a distinct style of testing. The term mock object gained popularity in the extreme programming community. Mock objects are sometimes confused with stubs, which are common testing helpers. There are two main differences between mock objects and stubs: how test results are verified, state verification versus behavior verification, and their impact on testing and design philosophy. There are two styles of test driven development: classical and Marxist, with mock objects being more aligned with the latter. Now, regular test. There are two styles of testing: classical and Marxist, as we previously discussed. X unit tests follow a four-phase sequence: setup, exercise, verify, and tear down. The setup phase involves preparing the objects under test, SUT, and its collaborators. The SUT is the object being focused on for testing, while collaborators are other objects needed for the SUT to function correctly. In state verification, the correctness of the tested method is determined by examining the state of the SUT and its collaborators after exercising the method. The distinction between SUT and collaborators is essential for testing oriented people. The classical style of testing emphasizes state verification. Mock objects enable a different approach to verification, emphasizing behavior verification. Behavior verification focuses on verifying whether the SUT interacts correctly with its collaborators during the test. Test with mock objects. The use of mock objects is demonstrated using the JMock library in Java. Two test cases are presented: one testing the behavior when inventory is in stock, and another when inventory is not enough. The setup phase is divided into data setup and expectation setup. Mock objects are used to represent collaborators, and expectations are set on them regarding method calls. Behavior verification is employed where the correctness of SUT's interaction with its collaborators is verified by checking if the expected method calls were made. Verification includes both assertions against the SUT and verification of mock objects. The second test case demonstrates different approaches using a convenience method for mock creation and relaxing constraints on expectations using with any arguments. The use of behavior verification with mock objects simplifies testing by focusing on method calls rather than state changes. Using EasyMock. EasyMock is a widely used mock object library available for Java and .NET development environments, enabling behavior verification and testing. It employs a record replay metaphor for setting expectations, where you create a control and a mock object for each object to mock. Expectations are indicated by calling methods on the mock object with expected arguments, followed by setting return values, if needed, on the control. Once expectations are set, a replay method is called onto control to finalize recording, and verification method or verify method is called to ensure expectations were met. EasyMock allows actual method calls on the mock object, facilitating code completion and automatic refactoring, but lacks the flexibility of looser constraints found in other libraries like JMock. The JMock developers are working on a new version to incorporate similar features, enabling actual method calls while retaining flexibility and setting expectations. The difference between mocks and stubs. Test doubles are pretend objects used in place of real objects for testing purposes, categorized by Gerard Meszaros into 5 types: dummy, fake, stub, spy, and mock. Mock objects are pre-programmed with expectations, forming a specification of the calls they are expected to receive, and they insist upon behavior verification during testing. Other types of testing doubles, like stubs, typically use state verification instead of behavior verification. State verification involves checking the state of the test double after the test, while behavior verification involves checking if the test double received the expected calls during the test. In testing scenarios where real objects are awkward to work with or need to be controlled, test doubles are often used. Stubs, like mocks, can be used as test doubles, but they can employ either state verification or behavior verification, depending on the testing needs. Mock objects are particularly useful when behavior verification is required, ensuring that tested objects interacts correctly with its collaborators during the test. Classical and Marxist testing. Classical test-driven development emphasizes using real objects whenever possible and resorting to doubles only when using real objects is inconvenient. Classical TD practitioners may use any type of double, such as stubs or mocks, depending on the situation. Marxist TDD, on the other hand, always employs mocks for objects with significant behavior. Practitioners of Marxist TDD prefer to use mocks consistently for both simple and complex objects. While Marxist testing frameworks were initially designed with Marxist TDD in mind, some classical TDD practitioners find them useful for creating doubles in their testing. Behavior-driven development, an offshoot of Marxist TDD, focuses on exploring TDD as a design technique by emphasizing the behavior of objects. BDD typically employs a Marxist approach but extends it with its own naming conventions and integration of analysis. The terms Detroit style and London style are sometimes used to refer to classical and Marxist TDD, respectively, based on the locations where these approaches were popularized. However, some Marxist TDD practitioners reject such terminology, arguing against a strict distinction between the two styles. Choosing between the differences. State verification versus behavior verification. In easy collaborations, classic TDDers use real objects with state verification, while Marxist TDDers use mocks with behavior verification. In awkward collaborations, Marxist TDDers always use mocks and behavior verification, while classic TDDers may choose between mocks, stubs, or other doubles based on convenience. Exceptional cases such as testing caches may necessitate behavior verification even in classical TDD. Classic versus Marxist TDD. Marxist TDD emphasizes using mocks for any object with significant behavior. Guiding design through need-driven development, classic TDD focuses on real objects whenever possible, with tests typically written to verify state rather than behavior. Classic TDD may employ a middle-out approach, focusing on the domain model first, while Marxist TDD often follows an outside-in approach, starting with the user interface. Fixture setup in classic TDD can be complex, requiring creation of all collaborators, while Marxist TDD only requires mocks for immediate neighbors of SUT. Classic tests may catch errors in client objects, leading to a ripple effect of failing tests, while Marxist tests isolate failures to the SUT. Classic tests are more coupled to implementations, impacting refactoring, while Marxist tests focused on out-of-bounds calls, potentially simplifying design. Marxist testing tends to promote avoiding methods chains and following the law of Demeter, encouraging tell, don't ask principle and role interfaces. Design differences between classic and Marxist testing are a key motivator for Marxists who advocate for a particular style of design supported by mock libraries. So, should I be a classist or a Marxist? Well, explore both approaches and make an informed decision based on your specific needs and preferences. On to the next section, test-driven development. Now, test-driven development is a software development technique pioneered by Kent Beck in the late 1990s as part of extreme programming. TDD involves three main steps: write a test, write functional code to pass the test, and refactor both new and old code. Before writing code, developers create a list of test cases and then select one to implement, iterating through the process. Writing tests first helps achieve self-testing code and encourages focusing on interface design, aiding in separating interface from implementation. Neglecting the third step, which involves refactoring code to keep it clean, is a common mistake in TDD and can lead to messy code. Now, key qualities of a good unit test. So, a basic unit test runs independently of the environment, other tests, external data, and side effects. Basic tests shouldn't rely on specific environments, other tests, external data, or cause side effects. A good unit test asserts code results tests a single unit of work and covers all code paths. Better unit tests edge cases, runs fast, and is well informed or well factored. What makes a good unit test? Well, WOMP's 5 laws of writing tests are as follows. Descriptive test method names, which use clear descriptive names to convey what each test is testing. Number 2, arrange, act, assert style. This organized test in a consistent AAA style for readability and maintainability. 3, provide failure messages. This includes meaningful failure messages with asserts to quickly identify the cause of failures. 4, comment the reason for the test. So explain the business assumption or purpose behind each test to preserve test integrity. 5, revert state resources. Basically ensure that every test reverts the state of any resource it touches, using mocks where possible to avoid dealing with real resources. Cleanup should be done at the test level to avoid reliance on execution order. Now, unit test versus functional test versus integration test. Unit tests ensure that individual components of the app work as expected. Assertions test the components of the API. Integration tests ensure that component collaborations work as expected. Assertions may test component API, UI, or side effects. Functional tests ensure that the app works as expected from the user's perspective. Assertions primarily test the user interface. Roles test play in continuous delivery. Each type of test serves a unique role in ensuring software quality. Unit tests verify individual components' functionality. Integration tests check component collaborations, and functional tests assess the app from the user's perspective. It's essential to isolate these test types to run them separately during development phases. During continuous integration, tests are utilized for developer feedback, staging environment validation, and production environment smoke tests. All types of tests, including user experience tests, developer API tests, and infrastructure tests, are necessary for comprehensive software testing. User experience tests evaluate the system from the user's viewpoint, while developer API tests examine it from a developer's perspective, focusing on the module's interface. Proper understanding and utilization of each test type contribute to effective software development and deployment processes. Now, software testing. Software testing is the process of checking whether software meets expectations. It provides objective information about software quality and the risk of failure. Testing can determine correctness for specific scenarios, but not all. Oracles, such as specifications and past versions, help measure correctness. Testing can be dynamic or static. Information from testing can improve the software development process. Finding bugs while testing software. Now, software testing involves handling bugs, which are defects in the code causing undesirable results. Bugs can slow testing progress and require programmer assistance to debug and fix. Not all defects cause failures. For instance, defects in dead code won't lead to failure. Defects may cause failures due to environmental changes like new hardware or data. A single defect may produce multiple failure symptoms, complicating troubleshooting. Now, software testability. Software testability refers to the degree to which a software artifact supports testing in a given context. Testability makes finding faults in the system easier through testing. Testability relies on the existence of a verification function that validates the system's output for a given input. Lower testability leads to increased test effort and may hinder testing certain parts of the software. Testing of software components is determined by factors like controllability, observability, isolability, or etc. Test-driven development and design for testability are methods to improve software testability. Requirements must be consistent, complete, unambiguous, and verifiable to be testable. Testability of requirements involves asserting the existence of a function that translates into the set indicator function for the specification set. Unit testing. Unit testing is a form of software testing by which isolated source code is tested to validate expected behavior. Unit testing describes tests that are run at the unit level to contrast testing at the integration or system level. Execution. Unit tests can be conducted manually or automated. Automated tests offer advantages like frequent testing, cost-free execution, and consistent, repeatable results. Testing criteria. Programmers encode criteria or expected results into tests to verify a unit's correctness during development. Frameworks log and report failed tests during execution, providing a summary. The test function expected value approach is widely used for this purpose. Test case. A test case in software engineering specifies inputs, conditions, procedure, and expected results for a single test. Test cases ensure methodical testing rather than random. A suite of test cases can provide desired coverage of the software. Formally defined test cases enable consistent regression testing across different software versions. Value. Benefits of unit testing include early problem detection, reduced costs, more frequent releases, supportive code refactoring, detection of changes, breaking design contracts, uncertainty reduction, and documentation of system behavior. Unit tests embody critical characteristics of the units, serving as a form of documentation and aiding in design. Mock objects. Mock objects stimulate the behavior of real objects and are useful when real objects are impractical or impossible to incorporate into a unit test. Characteristics suggesting the use of mock objects include non-deterministic results, difficult to create states, slowness, non-existence, or potential behavior changes, and test specific information or methods. Mock objects mimic real objects interfaces and can be programmed to return pre-arranged responses or imitate complex logic. Mock objects are often used in test-driven development to isolate functionality and focus test on the system under test without worrying about its dependencies. While mock objects offer benefits, they can also lead to tightly coupled tests, maintenance challenges and inaccuracies if not modeled correctly after the real objects they represent. Now, technical resources, JUnit 5. This is the current generation of the JUnit testing framework, which provides a modern foundation for developer-side testing on the Java virtual machine. This includes focusing on Java 8 and above, as well as enabling many different styles of testing. We also have Mockito. Mockito is a mocking framework that lets you write tests with a clean and simple API. With Mockito, the tests are very readable and they produce clean verification errors. This concludes my project. Thank you all for watching. I hope you learned and are able to utilize unit testing in your future endeavors. Thank you again. I am Reginald Santil, signing out.